Hi, today we are back here at the Powerwall, and last thing what we did was we discharged the battery pack overnight to basically zero, and then yesterday was the first day I let the charger run about 5 hours until it got cloudy and rainy, and then I discontinued. And today in the morning I started again, and now another 4 hours of charging. We're still in the phase of the constant current. Okay, our small meter reading 19.6 kilowatt hours. I have started at 5.7, so this is now extra 14 kilowatt hours since we started. The efficiency of this charger is 93%, so we have actually now put in 13 kilowatt hour into the pack. We are still in the flat part of the charge and discharge curve, so but after putting 13 kilowatt hour into the battery, we should slowly see rising voltages there up to the maximum voltage of 58.4. I measured the pack. The cells are sitting there quite nicely on the same voltage. Another probably 2 kilowatt hours and we should actually reach the capacity. Once we hit the maximum voltage, then we will tonight discharge the whole pack, and so we can calculate the capacity once from charging and once from discharging. Tomorrow morning we should actually know all about this battery. Okay, right, it's about 2 hours later and charging is finished. The voltage is now dropping again. I had to basically stop the charging process because this cell group already reached more than 4 volts. Typical BMS for lithium iron phosphate cells would disconnect the pack if one cell group reaches 3.7 volts. No, I did not see it because at the end everything goes pretty fast. But nevertheless, our small meter was showing 21.2 kilowatt hours. I started at 5.7. That means we have put 15.5 kilowatt hours into the pack. So you have to now calculate this with the charge efficiency by 93%. So we have actually put around 14.2 kilowatt hours into the battery. You know, we started around close to zero, maybe around 3%. Now 14.2 went into the pack. Not every cell group is up to the voltage because, you know, without BMS we cannot try to go too high. It's a good result. So we will prepare now the Powerwall for discharge. The breakers for the charge is off, and now we will flip on the breaker for the inverter. And the inverter will start operate. And you see, it's already putting out 800 watts, and the small value there remaining 12 watts, 10 watts on that phase which comes from the limiter. So almost all the load is removed. I have set this inverter to cut out now at about 47 volts. This is already well in the area of the final drop-off of the cells, and I have also set it to use up to 1250 watts maximum. So this is a 2000 watt inverter. The manual says the maximum continuous discharge is around 1920 or something like that. But I want to go very slow on the equipment. I want it to survive for a long time, because here in Thailand it's always hot. We have a temperature around 32 degrees now, and that's about the temperature which is present here all the time. Charging, discharging, everything slow. We're going easy on the pack and the rest of the system. Okay, so the discharge has started. Tomorrow morning we expect to find the place with a empty battery pack again, and then we will of course see how much we took. But I forgot, we have to first of course clear the meter here. So the monitor is now cleared and starting with 0 amp hours. Tomorrow we can then read how much we discharged. Right, I'll see you tomorrow morning. Okay guys, 2.5 hours later, and we will shortly reach the cutoff voltage of 47 volts, which I have set. The inverter has throttled down. Now only 120 watts. Yeah, I have checked the cell voltages. They are still always in limits. There are some strings which are around 3 volts, but this one is now the lowest with about 2.7. So I will stop the discharge. And what does the monitor say? We discharged 260 amp hours. So 260 amp hours. The first ever discharge and charge is over. What did we learn? You know, these are used lithium iron phosphate cells. I bought it in Thailand. I had no idea about the history of the cells, how many cycles they have, how many capacity was left, and now we have the result. So the last 2 days we have charged 14.2 kilowatt hours into the pack, and today, considering that maybe now there's about 5% capacity still inside the pack because of the cells are quite unbalanced. There's some cells still around 3 volts and like 2 or 3 strings starting to drop off slowly. So we discharged 260 amp hours, and I would say there's another 10 amp hours inside the batteries. What makes it a 270 amp hour pack? Translated to kilowatt hours, that's around 13.5. So the difference between 14.2 and 13.5, there's the efficiency of the inverter, which you have to consider. So the numbers match. So this was originally a 300 amp hour pack. Now we have 270 left. So the cells are degraded by 10%, which is probably acceptable. It's used cells. Who knows how long they have been used? We will never find it out. But 10% here in I have my experience with the other pack, with the lithium polymer. In the hot conditions here, in the hot temperatures, This is actually quite nice for the cells. They like temperatures around 30-35 degrees. And the degradation is actually slower than you would have in other climates. So I'm kind of pleasantly surprised. I'm expecting this battery pack hold for quite a long. And yeah, we will now start. Today is a beautiful day. It's again sunny. I will start the charger again because I don't want to let the batteries sit at a low state of charge. So we will charge back to around 50% and then no more testing until we get the BMS. I want to risk some damage by not watching the upper or the lower limits. But there's other things coming up soon. I already got most of the components for the controller. So probably within the next few days we will start building our controller for the system. It will be fun and an interesting experience also. Thank you for watching this episode. Please subscribe to see and not miss the rest of the videos which will come up soon. Thank you and see you again the next time.